Right? The rational root theorem says if there are any rational roots, and there doesn't have to be, but if there are, they must have the form of the factors of the constant term, that's usually the last term when you write it, divided by the factors of the leading coefficient, meaning the highest degree term, which is on the left. When we get to the next slide, you'll see exactly what that means. Okay, we ready? Taking too long. Right? So in this case, hopefully this is the first one. Okay, the constant term is this, right? Let me change that to blue. Right, the constant term is that. Right. The leading coefficient is whatever is the coefficient of the highest degree term, which is usually on the left, right? So in this case, that's the leading coefficient. So if there are any rational zeros, then we would know they have to be factors, one factor of -3 divided by some factor of 1. Okay, well, think of it. What are the factors of -3? Yeah, it could either be 3 times -1 or -3 times +1. Usually when you see them written like this, it'll always be written as plus or minus. They're always plus or minus. So it's plus or minus 1, plus or minus 3. Right? Those are the factors of -3. And then what are the factors of 1? 1 times 1 or -1 times -1. So we would say plus or minus 1. And now you need to take all the possible combinations of the factors in the numerator divided by the factors in the denominator. In this case, there's only 2, right? It's either 1 over 1, which is 1, or it's 3 over 1, which is 3. Right? That is a list of the possible rational zeros. How many are in that list? How many numbers are right here? Incorrect. There's 4. It's plus or minus, right? So how many, by the fundamental theorem of algebra, how many zeros might we have? There's only 3, right? So this is not a list that's saying these are all rational zeros. It's saying that if there are any rational zeros, they must be in that list. Okay. Now, normally the way you would deal with that, especially if you only got 4 to deal with, is you would do synthetic division, see when you get a remainder of 0. So I could take this list here and go 1, 1, -3, -3, and then just start trying your possible rational zeros. I'll try 1 first. 1 times 1 is 1, add. 1 times 2 is 2, add. 1 times -1 is -1, add. Right? Is 1 a 0? No, because it didn't give us a remainder of 0. Okay, try it again. I'll try -1 this time. 1, 1, -3, -3. And this time I'll do -1 in the bracket. Bring down the 1. -1 times 1, -1. Add. -1 times 0, 0. add. Negative 1 times negative 3 is 3, add, remainder is 0, so that tells us negative 1 is a rational 0. Okay. Now, what do these numbers represent? The 1, 0, negative 3. Right. They're the coefficients of a polynomial one less power than we started with, right? So it must be x squared minus 3. X squared minus 3. Right. And if you want to find the last two zeros, you set it equal to 0 and you solve. So x squared equals 3, x equals plus or minus the square root of 3. So those last two are irrational. So when they said in the directions, it just said find the actual rational roots, and the only actual rational root was negative 1. The other two are irrational.